So hello everyone, thank you for being here. My name is, as Kamil already mentioned, Marcin Moskala. You might know me from blog kotlinacademy.com. So if you know something like that, you haven't seen it, it's very likely there are many visits. There are thousands of visits every day, and this blog seems to be quite popular. As well as another work of mine that is a book, Effective Kotlin. It is right now available only online, as I stopped on paper distribution due to the international problems, but we'll resume it after everything gets to normal. And if you are interested in that, on our booth, you can find a link where this book is offered for just $5. So if you want to have it nearly for free, you can find a link on our booth. And also from the book I wrote with Igor Wojda, Android Development with Kotlin. Right now, I work for a company called Allegro. It's like a Polish Amazon. It's a really big company, actually. There are more than 900 microservices, around 100 teams of developers, and most of those teams, most of those microservices are written in Kotlin. We use it widely. We are probably the biggest Kotlin user, Kotlin users in Poland. Probably, I don't know exact statistics, but I don't know any such a big company in Poland using Kotlin in such a scale other than Allegro. So DSL, what are those and why do we need them? So DSL is an abbreviation from domain-specific language. So it's like a language inside the language, a small part used to define something specific. So an example that you are probably familiar with is a Gradle. So many people think that Gradle configuration is it's an own language. So it has elements like plugins, ID, implementation, etc. But actually, it's nothing else but just a Groovy code. So special features of Groovy make it possible that we can, in the scope of this configuration, use those nice elements. And it looks very clear. It's like we are hiding Groovy, we are exposing what we want to expose. And the same can be done in Kotlin. It's actually already possible to define your Gradle configuration in Kotlin. It's nearly the same. So if you compare the differences, it's nearly the same. And now it's using Kotlin, it's type safe, and you have all the suggestions. By the way, I would like to add at this point that you can ask the questions on the polls right now. And I will be asking Kamil once for a while if there are any questions, and I will be answering them. So DSLs were introduced into frontend with React. So React offers something called JSX. It's a part of JavaScript. It is compiled to something a bit simpler, but it's a part of JavaScript that looks like it is written in HTML. It is not, it's a JavaScript, so you can use all the JavaScript elements inside, but it gives us a very important advantages that we enjoy in our applications. So it very quickly spread it into our disciplines. So the same can be done in Kotlin. So this is the same, exactly the same view defined using Kotlin DSL with Kotlin React library. And so using Kotlin DSLs, if you write backend application and you need to make some static HTML, or if you do a front-end application, you need to define an HTML. Instead of using HTML, it's nice to do it in Kotlin in a type-safe way with all the suggestions. We will see it in a moment. But it's also popular in mobile world. So in iOS, Swift UI popularizes a Swift way to define DSL. And in the same way, in Android, there is an alternative called Jetpack Compose. So this is a DSL, a Kotlin DSL actually, used to define views currently for Android, but it is implemented in a way that it's it is relatively easy to make it multi-platforms. So probably in the future we can expect Jetpack Compose also for defining HTMLs and maybe even iOS views. This idea spreads further. This is the desktop, but it also spread it to the backend world. So it's nothing new actually. As it's nearly a standard in a Python or a JavaScript, but it's very new in our JVM world, as it was introduced with Kotlin. Maybe there were some Rails offered something similar, but it's not this scale. So Kotlin allows us to make DSLs, define endpoints and configurations. So, for instance, a Ktor framework lets us define how we should respond to a GET request to the following endpoint, to GET request to news/propositions endpoint, etc., etc. So this is the body of what should happen in such a case. Very, very short, very clear way to define backend applications. Much faster in terms of compilation time, startup time, than Spring that is based on annotations. Talking about Spring also started experimenting with Kotlin DSLs, and you can find a library that lets us define security using Kotlin DSL. So this is a much nicer way than a classic filters. And you can also find an experiment made by Spring Foundation, Sebastian Deleuze in concrete. This is their experimental ways to define Spring applications using Kotlin DSLs. So you can see here something similar to what we've seen in Ktor. We define our application, we specify classical configurations, we specify beans, we specify that how do we want to respond to different endpoints on our service. We specify converters, etc., etc. We can specify all in at once in a type-safe way using one big Kotlin DSL. Okay, so those are a few examples. I believe you can find more and more of them. If you are interested in Kotlin coroutines are nearly one big DSL. So the way how we yield elements in a sequence is a DSL. Like every coroutine builder is kind of like a DSL because there is a parent-child relationship between a child and parent. So DSLs are very important in Kotlin, and it's good to know about them. Now I will ask Kamil, are there any questions on the chat?
No, yet. There's only a message from Pallavi. I hope I read that correctly, that he has read the book Effective Kotlin and is good and a smooth read. Oh, there is one question from Raul Raja. What's your opinion that most DSLs in Kotlin promote a mutable builder style in which the compiler can't verify really what you are constructing? You are constructing the object unit with all the parts, compared to the immutable DSLs.
Yes, this is a problem. I mean, this is a common question. We can force user to define something in DSLs. Maybe I'll show it a little bit later. It's a common question, but it's not so beautiful and it's not so great. So we probably need to find out a nice way to enforce or maybe to verify on the compilation time that some concrete elements were set. I will not show you any immutable DSLs in this session. I will concentrate on the classic Kotlin DSLs. But thank you for the question. Okay, so I would like to show you how you can define DSLs, and I would like to start with the most basic building blocks. In Kotlin, we have something called extension function. So extension function is very similar to the normal function, but instead of a prefix notation like this one, we are using notation we are calling a function on an object. So if there is no big magic here, it's just a different way of calling functions. Clearly, this can be a normal function, either something like that or something like that. Those are both the same. The thing is, this extension function is nothing big. There are only two differences. One is that it's called on an object, and another is that in the scope of this function, we are using this to reference to an integer. And this is important, and this exists only in the scope of this function. Okay, maybe this notation shows it better. This exists here. This does not exist in here. Okay, because this in this scope refers this extension receiver. And the extension function, like any function in Kotlin, practically any, even suspend functions, can be defined with a shorter notation, an anonymous function. Instead of defining a function in a classic way, we can skip a name and set it to some variable. So right now, we are creating an object representing a function and storing it as a variable. So what we got in here is an object. It has different methods, but this object also have function invoke that can be used to call it. So if I ask to print it, I will have the same result. So I will have 30 printed. Okay. Function invoke is a very special function in Kotlin, as it's an operator, and this particular operator can be called in a shorter notation like that. So class is an operator. It means that this class is the same as dot plus. Invoke is an operator, meaning that dot invoke is the same as just calling an object. It's just a different kind of an operator. Okay, but my class is a bit special because it's not a normal function type. It's a function type representing an extension function. It's a function type that is created to represent an extension function. So it can also be called on an object. So in this way, it's very similar to an extension function. Okay, it's very important to understand the difference between my class and my class 2, where my class 2 is a normal function. In its scope, there is no such a thing as this. We need to reference the first argument, the first parameter using its name. And it's also called differently. The invoke is the same, the first notation is the same, but it is not an extension function, so the last notation is not possible. So you can see it is a bigger difference than just a notation here. My class is used differently, and so it needs to have a different type. And I hope that the type of normal function is clear to you. This is just a function from int and int to int. A function of an extension function is a little bit more complicated. It cannot be from int and int to int because it represents an extension function. We have a special function type for that. It's called function type with receiver. So in this case, int is a receiver with first place receiver type dot, and then a normal extension function, one parameter, one result type. Okay, and this shows us the difference between my class 1 and my class 2. And my class, as every anonymous function, can be defined using shorter notation. So we first had in Kotlin anonymous functions, but later Kotlin creators introduced lambda expressions that are shorter notations for anonymous functions, and the same in here. This can be defined using using lambda expression. This lambda expression looks like that. So we need to keep the argument arrow, and that's it. So notice that this type can be omitted. By the way, just like in here, omitted because it can be inferred from the left side. Even this type, even this name can be omitted because there is only one parameter. So instead of using it, we can use it. But this type cannot be omitted because if it would, we wouldn't know what is this in this scope. Okay, so the type needs to stay there. And if the type stays there, we have something magical inside. So in this small block, in this lambda expression, we have this used that does not exist outside of this block. So inside this lambda expression, we have this, and it references to the int. Outside, we do not have it. And this is something very useful. And I would like to, and we will use it on our next examples. And I would like to show it how it can be creatively used to initialize a dialog. So here we have a classical way to initialize a dialog. But if we use what we've just learned, we can make this strange function, anonymous function, on the dialog. And so in the scope of this function, when we initialize a dialog, we can reference it using this, okay? And this is a receiver. This is something that can be used implicitly as well as explicitly. So it can be omitted. So we made our dialog initialization a little bit shorter, but let's make it better. I would like just to add that we need to invoke this init function. It can be invoked in a few ways, just as we learned before. It can be dialog.init, as it's an extension function, but it can be also init.invoke or init and we invoke it. So those three notations are all the same. They are compiled to exactly the same thing. You can choose which one do you prefer. You should understand there is no big difference. I will keep the first one as I believe the most explicit. And now all the body of our initialization is in here. Everything else is a boilerplate. So let's extract it into a function. So in this function, we will get this init function as a parameter. We'll create a dialog. We will initialize it, and we will return it. And having all that, we can make our building much easier. So this is a classical builder for object initialization. We just say, hey, make builder, and we can say title is that, that is that, etc., etc. What is more, we have all the suggestions. So when I ask for a suggestion, what can I do in here? I can see what can I do in here. And as Raja noticed, I can make a mistake and initialize something multiple times, just like in a classic builder. I can initialize something multiple times and nothing will stop me from doing that. So it's maybe not always the most type-safe way, but nevertheless, it's very useful and we like it a lot. If you want to have a simpler way If you know Kotlin, you probably know it already, that instead of this whole make dialog function, you can just do something like that, dialog.apply, because .apply does practically exactly the same what we got here. So it invokes this lambda expression, and it returns the result. So this is a simpler notation that will be probably in most cases preferred, as it is more common, maybe more idiomatic. But nevertheless, it's good to know about this kind of dialogues, as many things that we use, maybe a sequence, in a sequence, we can yield some values. So this yield is nothing else but then a function on the receiver. So sequence accepts a function type, and this function type is a function type with a receiver on a sequence scope, and this sequence scope has a function called yield. So this is the same idea applied for building sequences. Again, I will make a pause. Is there a question? Is there anything?
No, right now there are no questions.
Okay,
Everything
I'm
is
still waiting. So if there is anything unclear, let me know. So let's have a little fun and push our idea further. So let's build our own DSL. Maybe we'll make a classic DSL, HTML. Maybe we'll start with make HTML. And what can we have in HTML? So we can have head. We have title, maybe my website, maybe we can have CSS. Okay. What else can we have? So we can have body, and I will keep it easy. We can make a nice hierarchy of elements in the body. Let's keep it flat for this for the simplicity of this example. I will just make it possible to make here an h1 title, maybe text. So some text 1, h2. Title 2, and more text. Okay. So let's build it together. We need to start from this make HTML. This is our entry point. So just like a sequence or like a make dialog, it must be a normal function that starts our builder. So what we got in here inside is this is a lambda expression. It means that we need to have a function in here. Okay, I will call it init. And the same could be said about head and body. But if we would make it possible, then first of all, head would be allowed everywhere, which is undesired. We do not want to allow head everywhere. We want to have only head in the scope of make HTML, or maybe even HTML. Okay. The same with body. And also we would like to have some relationship between them. And the same as with our dialog, okay, we make it possible to set up title only inside the make dialog. And we make it possible by using this function type of receiver. The same in here, we will make it possible by defining some builder in here, so maybe HTML builder, and defining those functions on a scope on this builder. So in here. And again, this title, this CSS, they must be only allowed in the scope of this head, not outside of it. And so head needs to make its own builder, head builder. The same with body, my favorite. body builder. Okay, and again classes head builder, body builder. By saying less and less in red, we can see we are going in the right direction. I will make it a little bit smaller. So head, so title, is it easy? It can be just a string. Maybe at the beginning it's a now, and later we'll set it with data. CSS is a normal function. Now we only have a normal function. So maybe content. This computer is lagging. It's a different one for the job, but thank you. Okay. Maybe text here as well. Okay, and this is a strange thing because this is a way we put a plain text. We cannot just put a plain text because a plain text cannot be invoked. In Kotlin, it would be just ignored. So we need to add this plus to make it invocable. And what is this plus? This plus is nothing else but, again, an operator. So this is a unary plus operator, operator on a string, because we definitely call it on a string. Unary plus, okay. So this is the same as calling dot unary plus, okay? And since this is an operator on this receiver, on this body builder, it cannot be used outside of it, okay? Cannot be used outside of it. And when it is called, we know that we need to add something into our body. So it seems to be working right now, but clearly it prints as nothing. So if you try to print HTML, you'll see nothing in there. And so how can we fix it? So the main idea is that when we invoke those elements, we need to store data somewhere. So the last elements, we need to hold data somewhere. The easiest way is to hold it in the same class we use as a builders. In more complicated cases, you might want to separate that, but for the sake of simplicity, we'll keep it in the same way. So I will make okay, so I will make a CSS and every time you add a CSS, I'm adding to my CSSs. About H1, H2, we need to differentiate somehow H1 and the text. So for the sake of simplicity, I will just use a value classes. Maybe something like that. And I will make something like elements. Normally, we would make some nice type hierarchy, but let's keep it simple. So this adds H1 text. This adds H2 with text. And this will add just a plain text. By the way, clearly those all should be private, etc., etc. I'm not doing that to keep it simple, but this code is waiting for some improvement, clearly. And more interesting part is what about those guys? So here we do not have a body. Instead, we have some sub parts. So the HTML builder should hold the fact that someone defined head And what is in this head? So it should definitely hold head builder, head builder, and body builder, because HTML builder holds head builder and body builder. Head builder holds its data, body builder holds its data. And those functions, again, they are there to call this function. We need to call this function so that head can be filled with data internally. So we need to call this function. What do we call it on? We need to have some object. So since we are not updating an object, we are creating from scratch. I assume it's impossible to make body multiple times. I will just make a head builder myself. Head builder, invoke an init on this builder, and finally I can store it on the head. Exactly the same story in here. One important thing to notice is that those three steps are not new to us. This is exactly the same what we make in a make dialog, the same what is done in apply. So create object, invoke this builder function on it, and do something with that. Store it, return it, do something with that. In this case, it will be return. Okay? This is a common pattern for DSLs, and it can be a little bit simplified. So let's just finish this example to show you that. To show you where we are, I will make all those objects data classes so you can see their content without necessity to define string ourselves. And it looks like this is it. So let's see what do we have in here. So this is how our builders looks like. Maybe let's make it a little bit smaller. We create builders, we fill them with data, we store them, perfect. And in the last operations, we are just adding to the builders. Okay, so what we got in here is an HTML builder with head. Head has title. It has CSSs. Okay, we have body builder. In body builder, we have H1 with title, some text 1, H2 with title 2, some text 2, H2, and some text 3. So we haven't missed anything. We got everything we need. So it seems like our DSL is functional. Now it's a trivial problem to parse these objects into some HTML and display it on a view. So with that, I'm pretty sure you will be able to write your own Kotlin DSL library. Okay, does that make sense? Are there any questions at this point?
There are no questions right now, so everything is clear. Okay,
so there is one problem though that needs to be noticed. By default, if we can do something on this receiver, let's say in this receiver we can use head, we can also use it on the lower receiver. So we can put the body inside a head. What does not make sense, but it is possible because of, we are, this is how extension functions work. So it's normal that when we have
I think what your connection was interrupted. I can't hear right now.
To prohibit that, and we have a way to do that. So we have an annotation It's actually a meta annotation. So an annotation to add annotation, and maybe I will call my annotation Kotlin DSL, and I will use this meta annotations, annotation DSL marker, and when I got it, then if I use my annotation before my classes, then it is prohibited. Okay, I cannot do that. I can only use the most the first receiver, so the receiver from the clear from the current scope, not implicitly from our next scope. Okay, but this is not the only use of HTML DSL. Another use is that if we use it before functions, here and here and here, and maybe even here, for here, here, then you can see they change the color. Maybe you remember it was there. Those were normal functions. Right now they are very clearly like having a different color. There are a few colors in the Kotlin repertoire. So there are 4 of them, and which one is chosen depends on, actually it depends on the hash of this function name. So if I change this function, makes something like that. Now my color is different. It's some green, like dark green color, and all my functions are in the same dark green color. If I name it different, like I have 2 on the end, oh, now it's purple, and all my functions are in a different color. So by changing a name, you can change a color that is chosen. Of course, this is fun for us. I would never suggest to change a name for having a different color. But if you do not like a color that is used, you can just click in here and you can change it yourself. So make it something like that. Does it work? It works. Okay. So we can have some fun with that. Okay. So again, any questions, or do you want me to show you one more example?
Yeah, so there are 2 questions. One is kind of parallel to what you're talking about, so I will leave it for a while. But the second is from Dennis. Have you ever built DSL for a real project needs using Kotlin, and could you share what project was it for?
Quite a few times we defined defined the data with Kotlin DSLs. True, but those are very simple DSLs. I wonder, some libraries I wrote. I'm pretty sure some parts of our I would need to think about it. I made quite a lot of them for different workshops and for different tasks. But me myself for own projects, I cannot remind myself a very concrete example. We quite a few times use DSLs to define data. So data structure, like you have a news, and on this news you can have title and content, etc., etc. So this is an alternative to defining these different objects using classic objects, and that gives you more flexibility. But it's those are very simple DSLs, not a very complicated one. One thing that I can definitely say I use DSLs for is that when I used DSLs like Cater or Cater, for instance, or Kotlin React, it's good to know Kotlin DSL because then you know how you can, for instance, extract some elements. So maybe this is some part, maybe this is an author view, and you understand why do you extract it in this way, and if you need to make it a bit more complicated, maybe get some more receivers from outside. Or if you need to make your own custom plugins, what I did for Ktor, again, using DSLs, you having the knowledge how DSLs are built makes it much easier to define those kind of elements. Ktor uses a lot of kind of magic that is clear once you know Kotlin DSLs. So a concrete object you need to place somewhere, a concrete type that you need to place somewhere, and if you do, then it is used as a receiver in some scopes, and yeah, this is useful knowledge for users, definitely. Much less often for creators.
Okay, thank you. So there's a second question. Pavel asks that most of the DSLs are done as applications, and even the one-shot ones like the brilliant DSL for Kubernetes configuration that was shown on the last Kotlin Conf is a library that requires creating a project, wrapping it in the main function, etc. And what's your opinion on using custom DSLs as Kotlin scripts?
Yeah, sure. I mean, it's still sometimes a bit problematic to configure Kotlin scripts in a project, but they do work fine, and if you configure them, and yeah, seems a totally valid approach for that.
Okay, so there's one more question that custom script definitions are really powerful tools for DSL creators, but Pavel hasn't seen them anywhere except of Kotlin Gradle DSL. And do you know why they are not used? And do you have any opinions about them?
So to be able to use them, we would need to import the library, which can be done with new Kotlin script. I think the primary reason why is, first of all, we still struggle with some problems with Kotlin scripts. I mean, most people haven't used Kotlin scripts yet, and so it's an additional problem to set it up at first. It also needs some, and Gradle do not need to worry about it because they knew that IntelliJ will support them, so we do not need to do that. So they are in a privileged positions. Yeah, I think this is the answer. I mean, it's totally valid way, but for now it's a bit harder to set it up for all the users. For code, you just take library and use it. For scripts, you will need to set Kotlin scripts and set how are they used properly.
Thank you. So last question from Raul. How do these DSLs validate when you miss a field that needs to be assigned? Does it throw an exception of some kind, or other way to avoid the user to run into an unexpected?
Yeah, so there are two ways. So one is if we want to force, for instance, if you want to force user to always define a title, we can make it an argument in here. So it can be title in here. We will need to change our definition a little bit, but you got the idea. And the change is very small right now. Without this title, our code will not compile. Of course, this is a good solution for a small amount of required fields, because if you have more of them, it is not beautiful and not, it's a little bit annoying. But maybe it should be if you have multiple required fields. So it's more like a philosophical question. About validating them, it is also a valid approach that is done in many libraries. So what we can do is that when we use it, we can just validate it even in here or during the parsing. So we can we will need to do it during the parsing, or maybe in here that the asset works on your unit test. So check not now builder dot title, and maybe some concrete exceptions. So title must be set. And this is a perfectly valid approach, which is not very central to the idea behind DSLs, as I believe DSLs were not defined with required fields in mind. So I think it is some requirement that was added later, or maybe at first Kotlin creators just thought, hey, let's just make an argument in such a case. And so right now I don't think there is any better way of doing that. It's perfectly fine if you have something required. You should check it as soon as possible. I hope it is clear for all effective Kotlin developers, and definitely for functional developers. Okay, one more thing I would like to add. We have 10 minutes, so maybe we'll not say it all, but I wanted to show you that defining web applications is not so hard neither. So this is exactly the same idea, web application, and we have a function. So I will make it an init, and again, web builder. So this DSL is nothing else but a Kofu application, practically all from the beginning to the end, and all the elements are nearly exactly the same. So login, beans, and router. Maybe let's skip beans. Or maybe let's show them. We have one interesting aspect. So it's quite relaxing. Writing DSLs. Okay, so logging is the simplest. In logging, we just need to specify the level. Again, someone might want to specify as an argument to make it required. Actually, it does not need to be required as it has some default. For our case, we'll just make it a property, and that's it. Beans are a little bit more complicated because we have a function here called beans that do not have any normal argument. All it has is so-called type argument. So some type, it's not a class, it's a type because it's nullable or generic. So it is something like it's a generic function, but it is not a normal generic function because in JVM we have a type arrays, meaning that during the compilation type, all those type arguments are gone. Okay, and we do not want to lose it. It's important for us. We want to reference it, so we want to be able to do something like that. It's impossible right now, but to make it possible, we need to use a feature called reified, which is only possible for inline functions. And once I have it, it's now possible. It's perfectly possible, for instance, to print type name, okay, and this way we say, or this way we pass this type, and based on this type, here I reference its class, and based on this class, I can, for instance, get constructors and maybe use them to construct an instance or to say that this is a bin, and I need to think about it when I inject something. Okay, so then we have C builder, and then this builder has a port and the router. So R, so function init and again I will just make it a little bit different because get, put, etc. They are what is in here. It is not an init function because this should be invoked immediately. This should be invoked immediately. This should be invoked immediately. But this is a lambda expression that should be invoked on demand when we have a request. So it's not an init function. It's a handler function. So we say, how do we want to handle this following on this following endpoint? So maybe I will call the first argument endpoint, and I will need to have a handler. And this handler is very small DSL itself, because in this handler we have elements like respond, or maybe elements like parameters, etc., maybe reference to header. So this is not a normal function. This is again a function type with receiver, and here we are going to have maybe get handler. Okay. And everything that is allowed inside needs to be in this get handler. So maybe there is params, maybe there is headers, maybe headers, header off, and headers and make it. And we have this function respond. So no time to implement it for now, but based on what we've learned earlier, you know how we can hold all this data. So based on this definition, based on that, we can easily make an object holding logging, pins, web MVC, etc., etc. It should be easy. Get, instead of calling this get handler, should store it. So maybe it should have a list of handlers. Maybe something more like a map. It's not a simple map. We'll simplify it to an endpoint to a handler. Of course, in the real case, it will be more complicated because not only an endpoint, but also a method. So get, often those endpoints will have some wildcards. So it's much more complicated, but for the sake of simplicity, you can imagine that it holds all those handlers in some kind of a map. So endpoint to handler, and so oops, and so when we have a request, all that is stored in this application. And so when we have a request, then based on this request, we are building some, based on this request, we are building some get handler. We are filling it with data, so we are putting the params, we are putting the headers, we are putting the all the data needed to respond. Then we use all this, use this big object to find a handler based on all the handlers we have defined. So we find the correct handler. This is it. And on the end, we just call it. So you might imagine it's not a very complicated task. Calling that would be just, finding web app builder dot router dot handlers, finding correct handler, and calling this function with this class on the first as the first position as a receiver. And that's it. I hope that this makes it clear how Ktor works, how Kof works. Does that make sense? Are there any questions, or can we wrap it all up and finish our today's session?
I think we are a few minutes after our time, but there's a question from from Pallavi. Is using DSLs to limit the scope of usages of functions, but not really for data creation, also a popular use case for using them, like how the function body here can only run inside the make HTML?
So I'm not sure. Isn't it the answer? Isn't it the question to? Sorry, isn't it exactly what we explained with DSL DSL market? So we can limit the scope that these beans can be used only in here and inside something or outside something by making this DSL builder meta notation and using it on the classes. Yeah. I hope this is the answer to speed it up. So if you see a builder like this one, literally 2 slides, very quick one. If you see a builder like this one, I hope it will be clear to you that those are all just a function. They are probably an extension function because this can be a normal function, but this can be also an extension function. There is absolutely no difference between those two. And this is nothing else but a lambda expression receiver. This is an unary plus operator. Some builders like Kotlin, like Gradle DSL, Kotlin DSL builder is much more complicated. So it uses elements like getters, infix functions, setters, etc. But those are still very simple Kotlin features. And then you know how to create Kotlin DSLs. It is almost too easy. I hope that you will keep this knowledge, and whenever you will have a problem with DSL, you will know how to solve it, you will know how to debug it, you will know how to read it, to know what happens over there. And that's it. Thank you. Reminding you that on the booth you can find the book for $5. So it's the biggest discount I could give. Thank you for today. And I will be on some other room where you can ask me more questions. Is it right, Kamil?
Yes, that's true. So thank you very much, Marcin, for this talk today. And for all of you, Marcin will be available in the discussion rooms after the talks if you want to ask him any questions unrelated to the talk he just gave. Thank you very much.
Thank you.